So this is the last installment of our 2014 webinar series, Energy Star Water Management Checklist. My name is Mike Turns, Senior Program Manager at PSD. We implement the First Energy New Homes program, which is why we're at the start of the Energy Star Water Management Checklist. This checklist is important because as homes get more efficient, they dry out less easily. So when you have a wall that doesn't have much insulation and it's not air sealed well, you have a lot of energy moving through, kind of like a blow dryer that can force moisture out if it gets in the building cavity. So inefficient homes dry out more easily. When you make it more efficient, it's harder to dry out. So if you do end up with any kind of problem, then it will not dry out, and you run into mold, potentially rot if it's really bad issues. So this is intended to make sure that as we tighten things up, as we add more insulation and make it harder to dry out, we're taking care of the details, which are best practice anyway, and most of the stuff is code requirements as well. So it shouldn't be a huge difference from, I think, a lot of standard practice. So there are 4 sections: the site and foundation, wall assembly and roof assembly, and building materials. So we'll be walking through those. Section 1 starts out with talking about patio slabs, porch slabs, walks, and driveways are all sloped 1/4 inch per foot away from the home to the edge of the surface, or 10 feet, whichever is less. So sloping porches away. And then also backfill has been tamped, and final grade is sloped 1/2 inch per foot away from the building for 10 feet. So here's an example of a garage on the left, or a driveway, sorry. On the left, you can see a pool of water there. It's obviously not sloping away from the house. So you need to get that 1/4 inch of slope for 10 feet, or to the end of the porch, or whatever it is. On the right, we have obviously a sloping away from the house, the garage there. That looks like it might take your bumper off when you pull in there, but that's the general idea, sloping away from the house. So the same thing goes just for the general grading all around the house. So the final grade has to slope away 1/2 inch per 10 feet. This is very similar to what the code requires. You can see on the left, it looks like it's sloping in towards the house the whole way, so that is bad, although at least they're attempting to get some of the water from the roof away from the building. Then you can't tell what's going on in the front of the house here, but obviously in the back we have a good slope away. So again, this is code requirement, pretty standard. Shouldn't be a big issue as far as getting your Energy Star certification. There are a couple exceptions. If you don't have the space, essentially, to get the slope that you need, you can install swales or drains that will carry the water away from the foundation. So if you're not familiar with the term swale, we're talking about basically a ditch, but it's sloped such that it will collect water and drain it away from the building. And here, it's a little hard to see, but we have a downspout here, and the drain is going underground and depositing the water, more than 10 feet away, and it's sloped away the whole time. So these are alternatives if you don't really have the space for the full 10 feet. Okay, as far as the foundation is concerned, we need a capillary break beneath all slabs. So that term, capillary, is capillary action. You have basically concrete will kind of suck up moisture. It'll wick it up from the bottom. So if the soil is wet below, you can get some wicking of that up through the slab, and you end up with moisture problems inside. So this capillary break is just going to keep moisture from entering into the slab and into the building. So we have 6 mil poly, so basically plastic. That's going to be lapped 6 to 12 inches. and taped, or it could be an inch of extruded polystyrene. So this is like pink board, blue board, that type of material, also with taped joints. So just a picture. I mean, I think we all know what poly under a slab looks like, or a foam under a slab. This is a downturned slab. It took me a second to kind of figure out what this graphic was showing, but downturned slab in this case with sheet poly and with foam running underneath it. So again, nothing that is really different than code here. So one without plastic, one with plastic. We want the one on the right. So the other alternative, like I said, is extruded polystyrene foam. So it does have some waterproof characteristics. Maybe waterproof is not the right term, but it will prevent the wicking of water from below up into the slab. Just make sure that you have the joints taped there, just like you would tape the joints in the 6-mil poly. Okay, so the capillary break for crawl spaces, basically it's the same idea, but then there are a few different configurations. So it can be placed beneath a slab if you have a slab, or it can be lapped up each wall and fastened with furring strips, or secured in the ground at the perimeter using stakes. So basically just want to make sure that it's staying in place. Here would be the example of you have your poly and then you have a little rat slab, many people call it, over top of that. So that's one option. That would be basically the same as slab on grade kind of deal. Here on the left we have some garbage, but we also have a lack of a vapor retarder there. On the right, this is a conditioned crawl space or an unvented crawl space. But what we're highlighting right now is the poly that's going there and extending up behind the insulation. So if you're not doing the rat slab, it should be coming up the piers and up the wall and fastened with furring strips to keep that solidly in place. I don't have a picture of one fastened with stakes, but I think we can imagine that. So the exterior surface of below-grade walls is finish of follow. So we're talking about damp proofing. Again, nothing that's not already required by the code. So we have this gunk that gets sprayed on there as damp proofing. This is showing that for concrete masonry walls should be parged first, and then the damp proofing installed. So this is where you have below-grade walls. On the left, you can see a lack of damp proofing is causing moisture to seep through and into the basement here. On the right, you can see the black coating is the damp proofing there, and just happen to be installing exterior insulation in this case. A couple more examples: CMUs without damp proofing, CMUs with damp proofing. If you happen to be using concrete forms, you're going to want to follow the manufacturer's instructions. So, you know, I'm honestly not familiar with their recommendations, but you want to make sure that there's something that's not going to react with the foam and deteriorate the foam. So, whatever the manufacturer recommends for damp proofing is what you should be doing in that case. There is also a provision for below-grade walls that are wood-framed, and unless I'm mistaken, I don't think that's going to be a very common practice, so I don't have any pictures of that in here, but you're supposed to have polyethylene, again, sheet poly that would be protecting wood framing that's below grade. Okay, so Class 1 vapor retarders should not be installed on the interior side of air-permeable insulation and exterior below-grade walls. I don't think that is common practice these days, but here is an example of what could happen if you have plastic over the studs on the inside of a basement wall. Air permeable insulation just means stuff like fiberglass or cellulose. But you can see some moisture has gotten trapped in there. The basic idea being that you're going to have wet soil outside a lot of the time, so potentially you have a high moisture content in that wall, even with the damp proofing, but hopefully that's helping. And if you put plastic in here, you're trapping that moisture in there. So if the wall does get wet, you want it to be able to dry to the inside. So you want this to remain vapor permeable. So craft-based bats are actually pretty vapor open in that direction. So that would be fine, but you don't want to have sheet poly across the inside. You don't really want to have that above grade either in Pennsylvania climates. Vapor retarder is not required in climate zone 4. It is in 5 and 6, although some would debate that. The only time you'd really want to have plastic on the inside is potentially when you're up in cold climates, so northern U.S. and Canada. Sometimes you see it on some of the Canadian TV shows, like on HGTV. That's because they don't have cooling loads, so their vapor drive is the same direction all year round. It's always for them, or almost always, going to be cooler and drier outside than it is on the inside. So the vapor direction is always from inside to outside, because water is going to move from warm to cold and from wet to dry. So you have this constant flow outward. So if you put plastic in there, it's going to keep vapor from getting into the wall, and that's a good thing. That would be bad in Philadelphia, where I'm sitting, because in the summer we have a number of months of air conditioning. The vapor drive reverses, starts pushing warm, moist air from outside to inside, and then it'll make its way through the cavity, hit the sheet poly, and get trapped. So that's what you don't want, is moisture getting trapped for any period of time. So we want that to be able to dry to the inside in a mixed climate like Pennsylvania. Sump pumps. So the sump pump well can be a significant source of moisture in a basement. So you want to make sure that you have a cover for that is gasketed and sealed and mechanically fastened. So here's a diagram showing it. A sump pump cover screwed in. We have no cover on the left. We have a nice cover on the right. You want to see what that might look like in real life. Drain tile is surrounded with clean gravel and fabric filter. So drain tile, or whatever you're using for your foundation drainage. So this foundation drain, I think this looks like more of a proprietary product than drain tile. But in any case, you want to have clean gravel. You also want to have it wrapped in that fabric filter, because you don't want sediment getting down and clogging that drain. If it's clogged, it's doing nothing, and failure is very common for these. So you want to make sure that you have it free and clear all the time. So that's why it's wrapped, and the clean gravel is also preventing sediment from getting in there. Okay, so here's an example. Looks like they kind of started to use the fabric filter, but didn't finish the job before the gravel was on there. Maybe this was they're in the process of kind of retrofitting it. On the right, we have one with fabric filter. This is sort of a different issue than the fabric filter and the gravel, but you can see that the drain has been cut with this penetration and not properly sealed. So that's a potential leakage point for water going into the basement. On the right, this was our picture of the damp proofing, but we also can see the drainage along the side there with fabric filter. Yeah, here another issue with the continuity of the fabric filter. So there appears to be some issues with basement penetrations and conflicts with the foundation drainage system. And you can have this attached to your sump pump system, making sure that that gets out from underneath the basement and drains away from the building. All right, so we're starting to get into walls now. So that was the foundation section. All of that, I think, is pretty standard practice these days, with the exception of maybe the fabric filter. That may not always happen, and getting good gravel surrounding the foundation drain. Moving into the wall stuff, flashing details are very important, keeping water out of windows and doors and other penetrations. This first one focusing specifically for masonry and stucco systems, making sure that you have weep holes and weep screed that allows drainage behind the masonry, and the water can flow out at the bottom and get pushed away from the foundation. So down here we have, you can kind of see it starting here. It would be underneath the building paper flashing. We're always starting at the bottom, working our way up. So, shingle fashion. So water is draining from on top of one thing to the top of the next thing. So we have a weep screed placed across here, which is going to, if anything gets behind the house wrap, it'll channel it away. But it's mainly because stuff draining on the house wrap will hit this piece of flashing at the bottom and drip off rather than dripping down onto the foundation. So here we have flashing extending underneath the foam. So again, that is okay, but there is no weep screed that's kind of coming down, extending out. So here we have a drainage coming from behind the foam, and that's extending out. This is the important part for masonry, making sure that you have some holes in the bottom with these weep holes installed in there so the water can get out, making sure that they are clear of debris and mortar and whatever else might be in there, so you have a path for drainage from inside to outside, from behind the masonry to the outside. So one on the left without any of that, no weep holes. One on the right has the weep holes. Same thing here. This one, I guess, has some weep holes, but not enough. You want fairly regular weep holes so water isn't pooling back there. Here's a diagram of a stucco system. There's some important details as far as stucco. You at least need 2 layers of building paper or house wrap. One is really a sacrificial layer. As you put the mortar up on the wire mesh, one of them is basically, it's going to get stuck to it. So you're left only with the second or the first one that you put on. So the first one, the outside one, they call a sacrificial layer oftentimes. Even better, you get some kind of drainage plane back there, like a 3-dimensional matrix material that will keep a gap back there. Because if you do get water stuck behind the stucco system, you can get into big trouble, and southeast Pennsylvania has had an issue with that, especially. So there's millions of dollars of retrofit work going on to remediate failed stucco. So making sure you have an airspace is ideal, but here we're just talking about drainage, and at the very minimum you need 2 layers of house wrap or building paper back behind there. Then you have the weep screed at the bottom that helps things drain away from the foundation. So here, no weep screed. Here we do have a weep screed. This is going to help the water drip down and not run down the side of the foundation. Here we have flashing on the window. Looks like they're getting ready to put stucco on. But you can see that there is a water-resistant barrier, which is another term for house wrap or building paper. That's behind that. But like I said, make sure you get 2 layers for stucco. And those are also code requirements. So again, nothing above and beyond code on this list, at least not much. So here we have some issues. Water-resistant barrier, wheat screed, and stucco lath are not properly layered. You need to make sure that everything is going on in the right order. So the building paper is allowing for drainage behind all of that, behind the wire mesh, behind the stucco, and then out at the bottom at the wheat screed. Okay, still with walls, we have fully sealed continuous drainage plane behind the exterior cladding, overlaps flashing, additional bond break drainage plane layer provided behind all stucco. So that's kind of what I was already talking about, having the 2 layers. You want to make sure everything is continuous and lapping in the right way. So like I said, start at the bottom, work your way up. Gaps like this are bad. This one is looking nice. I wonder who the builder of that one is. Foam. You can use foam as a water-resistant barrier in place of house wrap or building paper. You do want to have all the joints taped in that case and follow the manufacturer's instructions for installing this as a water-resistant barrier. But it is possible to kill 2 birds with 1 stone in terms of insulation and water-resistant barrier. Just really need to make sure you get the details of the windows and doors correct in terms of flashing. So one that's not fully installed, one on the right that is fully installed. So building paper's okay. Don't see that as much anymore. Window and door openings fully flashed. This is, like I said, a very important detail, very common source of leakage into the house. So starting at the bottom with pan flashing is required here. This could be, there are some flexible kind of real heavy-duty tape kinds of materials that can be used. There are also some plastic proprietary kinds of products, but or you can, make it out of wood and have a backer and make sure it's sloping away from the house. So all sorts of different types of pan flashing, but make sure that that's on first, and then you would put tape up along the jambs, and then your top piece is over top all of that. So it's in the right order. So water that's draining off of this top piece of flashing is going over top the jamb flashing and over top of the sill flashing. Also, as far as the house wrap is concerned, best practice is to have that on first. Again, follow the manufacturer's instructions for house wrap, or building paper if you're using that. But good to have that on first, so then you can do the sill flashing and pan flashing over top of that, and again, you have the water draining in the right way. And some of the manufacturers, you're left with a flap of house wrap over here that can then go down on top of this flashing, header flashing on top, and you would tape the corners of the house wrap there to finish things up. So getting the details on flashing, getting everything in the right order is important. Here we have an example where they didn't really get the corners, so water can drain down and enter at the corners here. This looks like good flashing. It looks like there's some kind of sill flashing. Not exactly sure what this is, but some kind of pan flashing. Tape over the top of that. The jamb flashing is over top. All of this is over top of the house wrap, which is good. So looks like the right order there. Okay, so another example, no flashing on the left here, no flashing installed along the sides of the window. So maybe this was just in progress. We'll give them the benefit of the doubt, but you do need that sill flashing as well as the flashing along the jambs and then the piece across the top. So kick-out flashing at roof wall intersections extending 4 inches. So step and kick-out flashing. We'll show pictures. So this is your step flashing, and you're alternating with the shingles to make sure everything is draining over top of the next thing. The building paper should really be extending down over top of that, so any moisture or rain that's draining down the house wrap is going to drain on top of that step flashing onto the roof and then down. This last piece, so you want this last piece of your step flashing to be turned up, so you have, or bent around, so you have this kick-out flashing. If you don't have that piece, water picks up a head of steam draining down the roof and will just shoot right over the gutter. And if there's an adjacent wall there, you get water just pouring down onto that wall, keeping it wet for long periods of time. And that's not good, particularly, again, with stucco, because it has a reduced ability to dry out once it gets wet. Here we have the step flashing. It's just not extending up to 4 inches up the wall that it's supposed to extend, so that's the problem on the left. A nice job there on the right. Integration with the house wrap is important. It does look like they have a piece of kick-out flashing, but the house wrap's going behind all of that flashing, so you're potentially getting that rainwater draining into the wall roof intersection. Here looks like maybe not the neatest installation, but the order looks right. They have the house wrap coming down below, behind, or over top of the flashing, and then they have it taped on there. So sticking with roofs, homes that don't have slab-on-grade foundation and do have expansive or collapsible soils, gutters and downspouts are provided so that they empty to lateral piping that deposits water on the sloping final grade, at least 5 feet from the foundation, or to an underground catchment system. So basically this is saying you either have gutters. There are some. I guess I'm getting ahead of myself. There's a way you can get around gutters, but I think Pennsylvania gutters are pretty standard, and people don't have issues with those. But you do want to make sure that this downspout is draining out and away from the house 5 feet, or it could be going into that underground catchment system. So it could tie into another drainage system that's going to take the water 10 feet away from the house. Or this alternative to gutters, deposit rainwater to bedrock, or you can have a rainwater management system, like a rain barrel kind of thing that you can have it draining into. So here on the left we have a downspout draining right at the foundation, which is not a good idea. You're going to collect all the water from the roof and deposit right here underneath the porch. So it's going to head right to the foundation. Here it's kind of obscured, but we have downspout, and then there's a hose that's taking that out and away 5 feet. Here the downspout just stops on the left. On the right it's going into a catchment system, so a drainage system along the foundation that's going to take that water 10 feet away. This is that alternative. I don't think it really applies, but you can see if you don't have gutters, all the water is just draining, and it's knocking, it's pounding out the soil here, so you can see where the water has been draining down. That's going to put a lot of moisture content in the soil and end up with foundation moisture problems. So if you really don't want to install gutters, they do have means for keeping the foundation protected with poly, gravel here. So there are ways around it, but I'd just stick with the gutters. Rain barrels, another option, and as opposed to draining it 5 feet away from the foundation, you can be going into a rain barrel, provided that it has going to have an overflow thing, so it's going to lead to the downspout if you do have a ton of rain or somebody's not maintaining this. All right, self-sealing bituminous membrane or equivalent at roof and valleys, roof deck penetrations. So it's kind of the snow and ice shield type of material. So that's protecting, it looks like a plumbing stack. Here's a valley, so that snow and ice shield there. Anywhere where there's the potential for water to pool, basically you're installing this to keep that water out. Here's another kind of it's a penetration. It's a roof wall intersection, so they've sealed that up with this bituminous membrane. So for climate zones 5 and higher, so that's most of Pennsylvania, unless you're in Philadelphia and the surrounding counties, you need to have this bituminous membrane at the edge of the roof, extending from the edge of the roof up 2 feet from the exterior wall, the plane of the exterior wall. So starting at the edge of the roof, and then you have the membrane extending up to the edge of the wall, and then going another 2 feet up, protecting the roof from, if you get ice damming issues, this is protecting the roof from leakage in those areas. So hopefully we have, insulation, good insulation all the way out to the eaves, and we don't have air leakage there, so we have low risk of ice damming, but this is an extra protection. Building materials. So we're not supposed to install carpet in bathrooms. Again, I don't think this is standard practice, but I have been in a carpeted bathroom before, so it is out there. They're just saying that you don't want wall-to-wall carpet or like permanently installed carpet within 2.5 feet of any of the fixtures, toilets, tubs, showers. There's the diagram, 2.5 feet from the toilet and the tub. Here's just to prove to you that some people do actually install carpet in bathrooms. So this is what not to do on the left. On the right, no carpet installed. So I don't think that's going to be a big problem for most of you out there. If you are doing tile or anything that has seams in it, you need to use a moisture-resistant backer, so cement board backer behind the tile. Not using paper-faced backer board like drywall. So this is just showing the cement board material installed around the tub. Same thing here, a little hard to tell what's going on, but you have one tub that doesn't have any backer, one that does have some backer. But again, the idea, you're off the hook if you're using a continuous like fiberglass tub surround or a shower stall, you're off the hook from that. You don't need to use the cement board. But if you're anything with a seam in it where water might leak in through the seam, you have to have that moisture-resistant cement board. Warm, humid climate zones. We don't really need to get into this for Pennsylvania, but Class 1 vapor retarder is not installed on the interior side of air-permeable insulation in above-grade walls. So we saw this requirement for not having it on the interior of basement walls because we have a constant moisture load from outside. But I left the slide in here, even though we're not warm, humid, just to say that, reiterate that you don't want to have anything that's vapor impermeable on the inside, even in Pennsylvania climate zones, because you don't want to trap moisture in the wall cavities in the summertime. So vapor retarders, but make sure that they're, you would want the class 2 or class 3, which you can even have as long as you have latex paint. So the vapor retarder is good, but make sure you don't have something that's totally vapor impermeable like sheet poly. Also, as far as building materials, you want to make sure that you're storing everything properly so they're not coming to the site or getting mold while on the site. If there is visible mold, you need to make sure that it's cleaned off. Also, if the framing has a high moisture content, you don't want to enclose that with drywall. So you need to make sure it's relatively dry. I think 18% is the Energy Star limit. 20-25% when you start to run into problems for if you have them reaching that moisture content for extended periods of time. So basically, proper storage is important. These trusses just sitting in the grass in the parking lot, not a great idea. They're going to come to the site with high moisture content, maybe some mold, but high moisture content, and then if they end up getting enclosed, you can end up with mold issues early on in construction or soon after the occupant moves in. Here we have some building materials nice and neatly stacked, and they're on pallets, keeping them raised off the ground. So that would be the best practice to prevent mold or high moisture content before you even have the house finished. Here's what a moldy piece of lumber might look like, so that can't be enclosed with drywall. Nice, dry, clean materials on the right. Here there's visible signs of moisture content. You can get a moisture meter to verify the moisture content of materials. But again, the key is just keeping things dry to begin with. You also might want to just check things as they come from the lumber yard to make sure that you're not installing wet building materials. And it's definitely an issue with tight, well-insulated homes. High moisture content can cause issues during construction and in early occupancy, which is not something a builder wants for their new occupants. Okay, so that runs through the 4 sections of the water management checklist. As I said, it's not a huge departure from what is already in the International Residential Code, the building code that's used in Pennsylvania. So really shouldn't give you too much heartburn. This is a builder-verified item. The rater can verify it, but the builder has the option to self-verify in this case. The other stuff has to be taken care of by the rater, or there's the one HVAC checklist that's taken care of by the HVAC contractor. So this one can be fully completed by the builder. It's sort of your own quality control thing. You're also signing off on it, so it is something that you have signed off on for documentation. So that does hold your feet to the fire to a certain extent, but it's not going to be something that's going to increase your rating cost as an additional rating, unless you want the rater to take care of it. That's your option, but you can verify that yourself as a builder. We like to keep this slide in as a standard slide in our presentations. The First Energy program requires Energy Star currently. So we're starting at 15-20% more efficient than a standard new home. But we also want to just point out that there are some programs that build off of each other. The Challenge Home, which is now called the Zero Energy Ready Home, that the Department of Energy has, and Passive House. These are all, each one requires the previous certification. So a Challenge Home requires the Energy Star, Passive House requires Challenge Home and Energy Star. So there is kind of a pathway that guides you towards very low energy or zero energy homes. So we'd encourage you to look into these other standards if you really want to set yourself apart as a builder. All 3 of these are good, but you can really start differentiating yourself as you move down on the HERS scale and into some of these more stringent programs. So, and here we have just calling out what our estimated incentives are for the various kind of tiers. These aren't official tiers with the program, but just examples of where you might end up. So Energy Star at $550. I think our average incentive now is a little under $600 for the base Energy Star. If you do something that's a challenge home, you don't get anything specifically for the challenge home label, but at those efficiency levels that we would expect, you might bump up your incentive to close to $800. If you get really low energy, maybe $1,000. And both of these can get significantly more. You know, all three of these incentives can get significantly higher with electric sources of heat, air source heat pumps, ground source heat pumps, mini splits, those types of things. Also, heat pump water heaters would help if you're considering putting those in. That's going to increase your kWh savings and increase your incentive under the First Energy program. So keep those in mind. This is an electric program, so the more efficient your electric stuff in terms of HVAC, appliances, lighting, the higher your incentive is going to be. Some additional resources that are good if you want to just look at the code. The code is available online at the ICC website, so we have that there. If you don't want to lug around a code book, you can get online and look at that. It's nicer to have the code book, but you can at least access code language there. Energy Star Home's website, keep that in mind. They have a lot of training and webinars that they do. So does the DOE as far as the Zero Energy Ready Home. Passive House has a website as well to lead you to the zero energy kind of area. And you don't have to do Passive House to get to low energy, but it's just something that has a little bit of name recognition. And Building Science Corporation has a lot of great materials. You know, they have a whole library. You could spend weeks reading through their stuff. So I'd encourage you to check that stuff out as well if you haven't already. So that is the end of the presentation. Thanks for joining. Hopefully you learned something and learned that the water management checklist is a builder checklist and it's not too scary. So this is probably, as far as Energy Star is concerned, this is probably one of the least scary components. You just have to kind of check off the things that you're probably doing anyway and what the code requires anyway. Just making sure you're paying a higher level of attention to the ceiling stuff, making sure that our tight, efficient homes don't get wet so they stay dry and you don't end up with problems. But so that completes the webinar. Thanks for your attendance. Hopefully you will check out some of the previously recorded webinars that are available when you log into your Compass account as a First Energy New Homes Program participant. So thank you, and